Alright, hello everyone. So welcome to my new trigonometric substitution video. Okay, so we are going to discuss about a very different type of trigonometric substitution problems in this video. Okay, alright, before we go into that, let's discuss about these three problems. Let's try to find the substitution. Okay, so what did we learn? It's so crucial that we review this. Okay, and then let's do a comparison with our hard tricky problem. Now in the first case, the substitute is going to be something to do with sine, right? So it's x is equal to sine theta. Now what is a? What do you think? So a square is 9, so a is 3, right? Okay, perfect. Here what is the substitute? So this is going to be secant, right? What is a? Again, a square is 9, so 3 secant theta. So here this is x is equal to 3 tangent theta, right? Perfect. Now I'm going to change this problem little bit. Look at what I'm going to do. Let's rewrite the first problem as 9 minus 4x square. Now what's going on here? So the only difference between this first example and this new example is that you have 4 in front of x square. That means, remember, in all the questions that I did in the previous videos until this video, never had a coefficient in front of x square. Well, there was a coefficient which is 1, but there was nothing other than 1, right? Now, how can we deal with this 4? Can we ignore this 4? I mean, like, can we take our substitute to be x is equal to 3 sine theta? Because the substitute is always, of course, x is equal to a sine theta, right? So a square is 9 here, so a is sine theta. Look at what happened. Now, what is the goal of a here? Choosing what do you get if you choose a correctly here? The thing is that you will be able to factor a common number inside the square root, and then you will be able to use Pythagorean identity. Okay, so let's see whether we can do that here. So here it's 9 minus, let's only focus about the square root part. Okay, so 9 minus 4, x square is 3 square sine theta, so it's 9 sine theta. Sine square theta, right? So 4 times 9 is 36. Wait a minute, if you choose that a, well, you can factor out 9 for sure. Okay, so it's 1 minus 4 sine square theta. Now, can you apply Pythagorean identity here? No, because Pythagorean identity says 1 minus sine square theta is cosine square theta, not 1 minus a number times sine square theta. Then you can't use Pythagorean identity. So what's going on here? Well, definitely our number here is wrong. We have to adjust the number. So how can we do that? That's what we are going to learn in this video. Now here's the thing. Let me write that previous example here again. Now we all know this is x is equal to 3 sine theta. Now this, so if you look at the general definition, it's a square minus x square dx. So substitute is x is equal to a sine theta. Now this x and a are placeholders. Now here look at what we do here. Here we have x square, so we take x here. So x is the placeholder. Okay, here we have a square here and we take a here. Okay, so we take the square root of that square right here. So that's really important. Now think about this example. Here's what I'm going to do. Here this is let's say 9 4x square. Now what is the placeholder here? Okay, well, that's not the best way to explain that. Okay, probably you understand it already, but okay, let me do something very important. Let's say this here we have, oh, that's look like 0, square square and triangle square. Okay, what is the substitute if triangle is the variable? Well, it's triangle equal to square sine theta. That's what I'm trying to get at. Okay, well, let's say this is as a. Then it makes our life easy. Okay. So that's what going on here. That's what I meant by placeholder. Okay. Whatever you have here, it's equal to, okay. Here you have triangle square. So triangle is equal to a sine theta. That's what's going on. Here the placeholder is x, like placeholder is triangle. So look what I'm going to do for this example, for our problematic example. Here, let's try to write this whole term as a let's try to write that whole term as a square. Then we can choose a new placeholder rather than x. So here 9 minus 4 is 2 square, so I can write this as 2x completely square. Does that make sense? Yeah, right. Okay, so then what is the placeholder? What is the triangle here? 2x, not x anymore. That's the difference between this problem and 9 minus x square. That's what I'm failingly trying to say. Okay, hopefully it makes sense. Okay, so the role that x had in a usual problem is now taken over by 2x. So whenever you have a coefficient in front of x square, okay, you have to write the whole term including that x as a complete square. Then your x becomes the new whatever you have here. So what is your new substitute then? 2x is going to be 3 sine theta, not x is equal to 3 sine theta. Here x is equal to 3 sine theta, but here now 2x is equal to 3 sine theta. Now again, like we choose a, whenever we have a square, we choose here we choose here a, right? Square root of a square. Here whenever you have a number, you take the square root of that. Okay, remember that very carefully and understand it. Okay, all right, so that's what going on in this example. All right, so let's do this problem. Actually, let's see whether Pythagorean theorem is going to work or not, and I will do another example in a new video. So 9 minus 4x square dx. Here's how you would do it really. So 9 minus here 2x square dx. So what is the substitute now? Not x is equal to 3 sine theta, 2x is equal to 3 sine theta. Okay, now I would like to take that 2 to the other side. Then it's clean. Okay, it's easy to work with. Now we have to take the derivative because we want to replace dx here, right? The usual procedure. So 3 over 2 derivative of sine theta is cosine theta. So dx is actually 3 over 2 cosine theta d theta. So we have everything we need to do the substitution. Let's do the substitution. Let's do that here. So here 9 square, where's the integral sign? So square root of 9 minus, we can use this form or this form, doesn't matter. Well, let's use this form. 2x is now 3 sine theta, so here 3 sine theta square, right? See how I did the substitution. Now we know 2x is equal to 3 sine theta, so I replace 3 sine theta here. Now you can see we can perfectly use Pythagorean theorem. You will see. Okay, or you can write 4x square. Here you can substitute again. 4x square is going to be the square of this. Okay, because now you're working with x. If you're trying to substitute it back into this version, okay, no matter what version you use, you will end up with the correct situation. Okay, but you have to be careful. If you are using this version, you have to use this version of the substitute. If you are using this version, then if you are substituting for x, you have to use this, right? Okay, now dx is 3 over 2 cosine theta d theta. Okay, so here it's 9 minus 3 square is 9 sine square theta. See, now you have a common number, right? It seems to be like it's working out. So let's factor 9 inside the square root. So it's 1 minus sine square theta. See, we can use Pythagorean identity. Okay, so if we use the Pythagorean identity, it's 9 cosine square theta, right? 3 over 2 cosine theta d theta. Alright, so square root of 9 is 3, and square root of cosine square theta is cosine theta times 3 over 2 cosine theta d theta. So this is 3 times 3, 9. So we can take 9 over 2 outside and cosine square theta d theta. This is what we get. Now we have to integrate cosine square theta. How do we integrate cosine square theta? Well, we have to use double angle identity. If you don't know that, you have to check my trigonometric integration video series definitely. Okay, so 9 over 2, so cosine square theta is actually 2 not 2, cosine 2 theta minus 1 over 2. That's the double angle identity. So it's cosine 2 theta minus 1 over 2 d theta. So let's take this 2 outside. So then it's become 9 over 4. You have to integrate cosine 2 theta minus 1 d theta. So 9 over 4, integral of cosine 2 theta is sine 2 theta. Let's have a bracket over 2, okay, because of this 2, minus integral of 1 is theta plus c. Now you know, before we convert this theta into x, I would really like to get rid of 2 theta terms in the answer. So sine 2 theta, by using double angle identity, it's 2 sine theta cosine theta. Okay, now 2 sine theta cosine theta over 2 minus theta plus c. 2 cancel out. So what we get is 9 over 4 sine theta cosine theta minus theta plus c. Perfect. Now let's convert them into the x values, right? So what is the substitute? We use the substitute. Remember, substitute is 2x is equal to 3 sine theta, right? Okay, perfect. Now then what we can do is we can divide by 3. So sine theta is 2x over 3. So this is the opposite side, this is the hypotenuse, right? So if you use that triangle, opposite side is 2x, 3 is hypotenuse, so let's call this c. So 2x square plus c square should be equal to 9 square by Pythagorean theorem. So 2x square is 4x square plus c square is 3 square is, here it should be 3 square, I'm sorry, 9 square, I'm getting myself ahead of myself. So c square is 9 minus 4x square, so c is square root of 9 minus 4x square, right? Okay, so we know the length of the missing side, which is 9 minus 4x square. So then let's rewrite the answer. Okay, let's see. So the answer should be 9 over 4. Sine theta is, we know, 2x over 3. Cosine theta is adjacent side, which is square root 9 minus 4x square, over hypotenuse is 3, minus, what is theta? So whenever you have the single theta, isolated theta, what you do is you take the inverse, right? So in theta is going to be sine inverse 2x over 3 from here, right? So it's sine inverse 2x over 3 plus c. So I would let you simplify this little bit. You can multiply this 3 and 3 and get 9. I'm little bit lazy, trying to save some minutes in this video. So that's the answer. So the big takeaway is how to deal with that coefficient in front of x square. Alright. Okay, I'll see you in future videos. Thank you very much.